So in part 1 we have computed the displacement and also we have shown how to compute the stresses in elements. Here this should be E1 and this should be E2. So now if we do a little bit of calculations, and then sigma 1 by E1 is equal to epsilon 1, and that is U2 delta T A1 E1 alpha 1 A1 E1 alpha 1 minus A2 E2 alpha 2 divided by A1 E1 by L1 plus A2 E2 by L2. This is U2, so this U2 divided by L1, so this is divided by minus alpha 1 delta T. So this is L1 L2, so this is delta T A1 E1 alpha 1 minus A2 E2 alpha 2 L1 L2, so this is L2, and in the denominator it should be A1 E1 L2 plus A2 E2 L1 minus alpha 1 delta T. Just continuing, so this is delta T A1 E1 alpha 1 minus A2 E2 alpha 2 L2 minus alpha 1 delta T A1 E1 L2 plus A2 E2 L1 divided by the same denominator. So here alpha 1 delta T A1 E1 alpha 1 L2, so this term gets cancelled with this term, and what remains is minus delta T, this term A2 E2 alpha 2 L2 plus A2 E2 alpha 1 L1 divided by this. So this is minus delta T, here A2 E2 alpha 2 L2 plus alpha 1 L1 divided by this. denominator. So this is the value of stress. Now if we try to verify the value of this stress, or this is actually sigma 1, and you have to multiply it with E1, and so this is E1, E2, because the previous value was sigma 1 divided by E1. So sigma, so we are multiplying again with E1. So this is for sigma. Now strength of material. So strength of material calculations, if you do, suppose I draw it again. So I draw it with a separate color, the thick one and the thin one. So now this is L1 and this is L2. Now what happens if you allow both of these portions to expand freely? Then what happens? Then this blue one goes here, say the blue one goes here, and the green one goes here, say. So this much is the free expansion of the blue puff portion, and this is L1 alpha 1 delta T, and here to here, so here to here is the free expansion of the green one, and this is L2 alpha 2 delta T. Now so we have to, but final position is somewhere, but the final position is somewhere in between. Say this is the final position. That means finally the blue one is here and the green one is so this is before the temperature increment is applied, and this is after. So now that means here you have applied a force P to bring it here, and here you have applied a force P to bring it here. So this we call delta 1, and this we call delta 2. So the first equation which we get is delta 1 plus delta 2 is equal to, so delta 1 plus delta 2, that means here to here, delta 1 plus delta 2 is equal to L2 alpha delta T plus L1 alpha delta T. So this is L1 alpha 1 delta T plus L2 alpha 2 delta T. So this is the equation which we get. So delta 1 is, now here you see delta 1 is P L1 by A1 E1, and delta 2 is P L2 by A2 E2. So P into L1 by A1 E1 plus L2 by A2 E2. This is delta 1, this is delta 2, equal to L1 alpha 1 plus L2 alpha 2 delta T, and P is L1 alpha 1 plus L2 alpha 2 delta T by L1 by A1 E1 plus L2 by A2 A2. So it's equal to A1 E1 A2 E2 L1 alpha 1 plus L2 alpha 2 delta T divided by A2 E2 L1 plus A1 E1 L2, and sigma 1, that is in the blue portion, is P by A1. So this is A2 E1 E2 L1 alpha 1 plus L2 alpha 2 delta T divided by A2 E2 L1 plus A1 E1 L2. So this is what we get from strength of material calculations. So if you check delta T A2 E1 E2 A delta T A2 E1 A2 L1 alpha 1 plus L2 alpha 2 by A2 E2. So here we have made a mistake. So this is A1 E1. Yeah. So A1 E1. So this is A1. This is A1 E1 L2 plus A2 E2 L1. So the results match. So the strength of material calculations and the finite element results are identical. Okay. So thank you.